We present our work on fusing event-based and RGB camera for robust object detection in adverse conditions. This work has been done by Team Chroma at INRIA. We discussed the project idea in the introduction. In the methodology, we discuss the training and evaluation schemes, and finally, we present our results and conclusions. The task we are trying to solve is robust object detection in adverse conditions, utilizing the complementary nature of sensors. The motivation being that event camera works well in high dynamic range scenarios and integration of the sensor redundancy. The main challenges were unavailability of labeled dataset and lack of detailed evaluation in adverse driving conditions. DSEC dataset contains RGB images and events recorded in a stereo setup. However, dataset lacks ground truth labels and bounding boxes. The generated object detection labels in RGB frame are transferred to an event frame with an homographic transformation. In this work, we propose a fusion at multi-scales method to combine the RGB and event data. Both inputs are passed through a separate ResNet50 feature extractor before combining them at the feature pyramid layer of RetinaNet. We use RetinaNet as a baseline model that is trained for single input modality. For dual sensor modality, we evaluate the FPN fusion and early fusion method that takes concatenated RGB and events channel as shown in the figure. We consider two representations for event streams, the voxelized representation into bins and the conversion of events to grayscale images. All models were trained on clean dataset and we use image dropouts. Evaluation was done with RGB images subjected to 15 corruption types over 5 severity levels. In the video, a sample detection performance is shown. It can be seen that the events only model fails to recognize objects that are far away. Although early fusion performs slightly better, but fails to learn the transformation between frames. On the other hand, fusing at multiple scales improves the overall detection performance by 7%. As shown in the figure, the original RGB image is transformed to an event frame. As visible in the table, the performance of all models improve with homographic transformation. The robust performance metrics show that the RetinaNet50 is highly sensitive to corruption. The FPN fusion model with event voxels and RGB attains the best performance. Generally, it is seen that the conversion of events to grayscale reduces the overall robustness. In the presented figures, we observe that different corruptions non-uniformly affect the performance. The video presents the object detection abilities under severe corruption. While a human can perceive the objects, the RetinaNet with RGB inputs completely fails. From the table, it is clear that in scenarios such as impulse noise, where a variation in model performance was seen, the FPN fusion edges over the early fusion method. Conclusion, we state that with the input representations, RGB and events combined increase the model robustness in adverse conditions. Event voxel is better than event gray for robustness. For non-homographic transformation, we say that the fusing dual sensor modalities at multiple scales generally perform better compared to early concatenation. For homographic case, it improves the overall performance for all models. Thank you.